charge of an electron is very, very simple. So what is the purpose of this particular experiment? Aim. So whenever you try to answer for any theoretical question, first you write the topic aim. So what is the aim of this question? To calculate the charge of an electron. And what is the principle? So whenever you drop any object, it just falls freely due to the force of attraction or acceleration due to gravity by the earth. So the same way, the freely falling uncharged oil droplet whose behavior was studied by Millikan's. At the same time, the uncharged oil droplet was converted by him as a charged oil droplet, and then whose behavior was studied in the presence of the electric field. So the behavior of a uncharged oil droplet while it falls freely was studied, and then the observation was noted. Then the same oil droplet was converted into charged oil droplet, and then when the charged oil droplet was made to move under the action of the applied electric field, whose behavior was studied by Millikan's. So those two behaviors actually combined together helped the Millikan's to calculate the charge carried by or possessed by the particular charged oil droplet. So this is a very simple thing. When he applied the electric field across two plates on the charged oil droplet, the charged oil droplet was made to move up and down, and by applying a suitable electric field, and the charged oil droplet was kept in balance in the field view of a telescope, and it was actually, what I am trying to say is, the charged oil droplet was made to stand as if still hanging in the free space. So he attained that particular beauty by applying the suitable electric field in his experiment. Now we can able to see the experimental arrangement. Now I will show the textbook, you can able to understand and what it is. Now look at the diagram. So this is the experimental setup. So the experimental setup contains a big bath. It is referred by letter D, and inside it contains the entire bath contained a dry air in it. So the whole, you can see in the diagram, which are actually shaded, it is called as a bath, a huge bath, which contains a dry air in it. Exactly at the center, a concrete pillar is built. Exactly, you can imagine like this particular room. The room can be understood as a chamber and called a bath, and which contains a fully dry air. At the center of the room, the center of a chamber, a concrete pillar is actually built. On top of it, a circular metallic disc whose diameter is about 22 centimeter is placed on it. But in the textbook you can see like a horizontal line. It's not a horizontal line, it's a circular plate is placed on it, whose diameter is about 22 centimeter. And then just above, with the help of a two ebonite rod or a glass rod, it is understood that the length of the glass rod and ebonite rod must be of a 16 millimeter. So with the gap of 16 millimeter, another circular plate which has a hole at its center is placed on the two ebonite rod. So what I am saying is, the two circular metallic plates are actually placed within a distance of 16 millimeter with the help of a two ebonite, or it can be of a glass rods. And above the hole H, a long pipe is actually provided, which has a small opening called atomizer. It is referred in your book as AT. AT means atomizer. It has got a small nozzle, and then on the outside of the long pipe, a small vessel is placed, and which contains a highly viscous liquid, namely like glycerin. When you just pump this particular area, yes, glycerin is actually pumped through pipe, and then the glycerin will be coming out from the nozzle as a kind of in the form of a droplet. So when you pump very slowly through the atomizer, a droplet actually comes out and falls through the hole which is provided on the top of the circular plate. So you have already studied. The next thing is we have to understand the derivation law. In the 11th standard, you have studied the Stokes law. I just recollect the idea that you have studied in the 11th standard. So this is a big jar. This was a big jar in which a highly viscous liquid like castor oil or glycerin can be filled inside. When you allow the circular metals, the metallic spheres, the spherical metals, when they are like what's called ball bearings. When you drop the ball bearing, which is nothing but a metallic metallic sphere. So once they come here, once they touch that glycerin or highly viscous liquid, they travel in a zigzag manner, and after reaching one particular state, they will travel with the constant steady velocity, and that velocity you call as a terminal velocity. So after reaching the terminal velocity, due to the weight, the weight of a metallic ball, the ball is moving with a constant steady velocity towards the downward direction. But on the upwards and on the other side, on the upward direction, it has a frictional force and a buoyant force. And this frictional force, due to the friction between the two different layers of the liquid, I hope you have understood what I am telling. And this U is the liquid. Whenever the liquid is displaced, whenever the liquid actually the ball is coming, when the liquid actually pushes at the bottom, they are actually moving towards the upward direction. So one layer is moving upward, or I can say that the layer of the liquid which is so close to that, which are in contact with the metallic ball, will be moving upward. The other layers are actually will be at rest. So between the two layers, some sort of friction will be present. That is shown by a letter F, which is pointing towards the upward direction. At the same time, the displaced liquid itself will have some upward force. That force is known as called buoyant force. So same way, when a droplet simply falls through the holes in the free space between the two circular metals. So in the previous case, we understood the metallic sphere is falling through the liquid, but here you have to understand the droplet, ordinary oil droplet, is falling in a medium called air. I hope you can have to compare the earlier topic and the present topic. So now in the case of silicon oil droplet experiment, the oil droplet is actually falls freely under the action of gravity in a free space called in air. So air gives the upward buoyant force as well as the frictional force. So now you can able to understand that weight of a droplet is equal to F plus U. Then if you want to calculate net downward force, F is equal to W minus U. What is called W? W is the weight of an oil droplet. How to calculate the weight of an oil droplet? It's a very simple thing. So W is equal to M into G. How to calculate the mass? Since we are talking about the shape of the oil droplet, it's almost like a sphere. So density is equal to mass by volume. The volume of a droplet can be understood as a sphere. This V is equal to 4 pi 3 I R cube. But here we can take the A cube. So volume M is equal to rho into V. So mass of a oil droplet M is equal to 4 by 3 pi A cube into rho. So the volume I have written is the volume of a sphere. Since understanding that the volume of the shape of a oil droplet is like a spherical shape, so that you can apply the volume of the spherical formula, sphere formula. This rho indicates the density of a oil droplet. So we can substitute in this formula. So we can say 4 pi 3 pi a cube rho into G. So suppose if I am standing here, wherever I go, suppose if I go and the air displaced my body, whose volume, no? The volume of the air displaced my body is equal to volume of my body, correct? The same way, when a droplet comes down, when descends down, the volume of air displaced must be equal to the volume of an oil droplet. So it is with that idea you can able to understand, you can able to calculate the weight of a air displaced. So this is also this is nothing but a force given on the oil droplet in an upward direction. It's called buoyant force. This is nothing but 4 by 3 pi a cube and sigma into G. So both are exactly similar. Okay, so 4 by 3 pi a cube, here also 4 by 3 pi a cube. One can easily understand that volume of air displaced is equal to volume of the oil droplet. And only one thing is different. The rho is the density of the liquid and the sigma is the density of the air. So substituting in this formula, the net downward expression F is equal to 4 by 3 pi a cube into G and rho minus sigma. And according to the Stokes law, the F is equal to 6 pi eta AV. So everybody knew that, 6 pi eta AV. So equating the both sides, you can be able to calculate the radius of a oil droplet which falls freely under the action of gravity. So you cannot be able to calculate that radius of the oil droplet with the help of a screw gauge or a vernier caliper. So using this particular concept, one can be able to calculate even radius of the oil droplet. Imagine. So A is equal to, when you just equate, you can understand 9 eta V by 2 into rho minus sigma into G to the power of half. Okay, so when you cancel, this becomes A cube, this A square. So here is A square. So our aim is to calculate only A. So automatically 9 eta V by, what is V? V is the terminal velocity possessed by oil droplet when it travels with a constant steady velocity through the space in between the two metallic plates with a constant steady velocity. We are assuming that constant velocity called terminal velocity as V. Now we are going to study about what happens to the charged oil droplet when you apply the electric field between the two plates. So I write the earlier question. A is equal to 9 eta V by 2 into rho minus sigma G to the power half. By applying X-rays, when you look at the diagram, we are applying the X-rays through one side of the chamber. So inside the chamber, what is present? A dry air is present. One of the properties of the X-ray is to ionize the air or a gas in which it passes. So in the dry air will be ionized by passing the X-ray. So ionization means it is converted into positive ions and negative ions. So at the same time you have to apply the potential difference of 10,000 voltage across the two metallic circular plates. So the two metallic circular plates will act as the electrodes. So applying the 10,000 voltage across the two metallic plates, and you have to pass the X-rays through the chamber. So the X-ray will ionize the gas or a dry air which is trapped inside the chamber. So then when you just pump that the atomizer, the ordinary oil droplet will pluck one or two negatively charged ions, so it becomes a negatively charged oil droplet. I hope you can able to understand. So ordinary oil droplet becomes charged oil droplet by plucking one or two electrons from the negatively ions of the negatively charged ions of the air.